Hello, everyone. This is Group 1, presenting Air Pollution Emerging Technologies. Group 1 members consist of 1. Yasmin, me, 2. Amenti, 3. Taylor, 4. Sam, 5. Georgia, and 6. Donald.
Our article came from Georgia Tech, published in the year 2025. Our article's title is Direct Air Capture Center. The main point being, after a heavy reliance on fossil fuel, heavy amounts of carbon dioxide are being released into the air. This has caused our global temperature to rise, along with our oceans to retain 30% of the carbon dioxide from our atmosphere. Georgia Tech has been developing a direct air capture DAC, which utilizes chemistry to help remove CO2 from our air. The process for this goes as following: grabbing the CO2 from the air, collecting said CO2, heating or steaming the CO2 from the absorbent bonds so the carbon dioxide can be transferred, and disposal of the CO2. Disposal of the carbon dioxide can be one of two ways. First being sequestering the CO2 underground, which is essentially storing it underground, or 2, to repurpose the carbon dioxide for commercial purposes like clean fuel.
So, why direct air capture? After more than a decade of research, models developed by Georgia Tech researchers now show that efforts to reduce current and future emissions alone will not be able to limit the global average temperature rise below the level needed to prevent the worst impacts of global climate change. With this in mind, it is suggested that negative emission technologies, or NETs, will need to be developed and deployed to stabilize climate change. The significant contributor to global warming is carbon dioxide, which traps the heat from the sun and increases global temperature in what's typically known as the greenhouse effect. So, one of the ways that negative emission technologies counteract this effect is by directly capturing and removing it from air. Taking the current and future projected level of carbon dioxide emissions, it is estimated that we will need to remove about 10 gigaton carbon dioxide per year by 2050 and increase that level to 20 gigaton carbon dioxide per year by the year 2100 in order to achieve the negative emission level required to stabilize the climate change. So, how does this direct air capture technology work? The researchers are making use of amines, which are nitrogen-based organic compounds that are derived from ammonia. Amines are very sticky by nature, and this allows them to form carbon-nitrogen bond and hold carbon dioxide captive. Manufactured amine-modified solids are then coated onto structures like monolith, similar to car catalytic converters, which allows air to pass through it efficiently. Generally, this whole process involves about three steps: capture, release, and store. First, air passes through the monolith, then carbon dioxide binds to amines, while most other components pass through with the exception of some water molecules. Once it reaches the optimal capacity, the machine then moves from the capture to release stage. This process requires energy, which is applied in the form of steam. The applied energy, which by the way will be recycled, warms the chamber to about 60 to 120 degrees Celsius, and this allows the purified carbon dioxide to be released for the next step, which is collection and storage. Once carbon dioxide is captured, there are two primary solutions: to either store it underground, where it will undergo further chemical reactions to become a mineral, or it can be used commercially as a form of clean energy source or for fertilization purposes. Despite its potential to fight climate change, the direct air capture technology has its own challenges. One is the fact that it will have high cost of operation. Second is that there still needs to be extensive level of research on how to make use of the captured carbon dioxide.
While this technology seems very innovative and a perfect solution, we do have our doubts about it. DAC technology is very innovative, and our group wonders if the sustainability of the device outweighs the emissions to create it. The article also states the cost for creating the DAC technology is going down, and our second worry is if the cost is going to decrease enough that it is worth the price to create and maintain the structures. And finally, Our third concern is regarding the environmental impact of the devices. While yes, the devices will reduce the CO2 levels in the air, we are concerned about other negative impacts the devices might have on the local environment and wildlife.
Here are the key takeaways from this presentation. Direct air capture, or DAC, is a technology that pulls CO2 directly from ambient air, rather than capturing it from emission sources. After capture, the CO2 can be either stored permanently or used. The importance of DAC. Many climate models show that simply reducing emission will not be enough. Some negative emission or carbon removal is necessary to stay within safe warming limits. How does it work? Ambient air is pulled in by large fans. That air then passes over a capture material, either solid or liquid, that binds the CO2 molecules, which are then stored. Cost and efficiency. DAC must use clean energy to not negate the net benefit of the system, which can be costly. Also, the required amount of DAC needed to meet the yearly goals of CO2 reduction can also be costly. Individual contribution. With the total overall population continuing to rise, causing a steady increase in fossil fuel usage, we must all take it upon ourselves to reduce our carbon footprint as much as possible.
To review about the article for emerging technologies, focusing on the direct air capture by Georgia Tech's innovation. Um, the direct air capture, DAC, is a new technology that removes carbon dioxide, CO2 directly from the air, not just from factories or cars. It's important because cutting emissions is no longer enough. We also need to remove CO2 already in the atmosphere to fight climate change. So the objective is that this is a demonstration of a key role in accelerating the development to deployment for the direct air capture. And what we're seeing is that we actually need to make this scalable to larger real world systems. If we don't start soon, we're already seeing a worsening with air pollution and climate change. But what makes the DAC, the direct air capture, different than other technologies? We're seeing that it's novel and it's increasing essential approach to removing carbon dioxide directly from the atmosphere. It's rigorous in innovation, prototyping, and validation, which are supported specifically from the research and industry collaborations. So this is a very unique emerging technology that we're seeing in environmental engineering. It also supports pre-competitive research, which is crucial in this early stage for research and development technologies. We're also beginning to also see that collaboration is critical because we want this to be a novel idea, and we don't want to have a copycat of another product. And with that, you'll see that there's a lower risk and the increase of the pace of progress that we're using, and that this is a truly novel idea. We also see that the center's interdisciplinary approach ensures that the emerging technology is technically competent, but it's also economically acceptable, viable, understanding environmental responsibility, and making sure that it's socially acceptable amongst communities. We're also seeing that the policy, the equity, and the environmental systems are going into the R&D process, and that's what makes this emerging technology so special by Georgia Tech. Air pollution and emerging technologies in the news. If you happen to have any questions, please feel free to leave them in the thread below.